Welcome to the Bentley Systems training course where we will show you how to design concrete structures using the STAAD Advanced Concrete Designer RCDC. The STAAD RCDC can design slabs, beams, columns, and shear walls along with open footings and pile caps. In this video, we will be focusing on the design of our concrete columns and shear walls. Before the columns and walls can be sent over to the STAAD Pro Advanced Concrete Designer, the RCDC, we must first analyze the model in STAAD Pro. Now for this particular model, we went ahead and modeled all of the concrete columns and walls. And what you'll notice is that all of the walls have been modeled as linear elements with the appropriate section properties to reveal a length along the wall. Now once you are done with your modeling process, you can go ahead and analyze the model. And then you're going to stay in the modeling mode once you're done. Now when the concrete columns and walls are opened in the STAAD Pro Advanced Concrete Designer, the RCDC, all of the member properties and specifications will be imported. In addition, the model will understand the supporting loads, materials, and analysis properties that took place in STAAD Pro. When you're ready to send your model data over to the STAAD RCDC, we are going to close down STAAD Pro and then launch the STAAD RCDC from the icon on our desktop. Here we're going to name our project and specify our appropriate design code. Here we're going to select the ACI 318M 2011 code. Next we're going to select the model that we just analyzed. Once that's selected, we're going to have the option to select our columns and walls, and then we're going to create a new project. All of the model data is going to be entered in, and then we're going to see all of our columns have been entered. As the columns and walls are brought into the RCDC, the geometry data from the analysis is read. The STAAD Advanced Concrete Design RCDC identifies members constituting a single column from bottom to top. It identifies floating columns, columns stopping at various levels, inclined columns, and columns split into multiple columns. Before the columns can be designed in the RCDC, we must first review the loading information. To start this process, we're going to go up to the Settings menu and then select Basic Load Cases. Here we're going to see that all of the analyzed load cases from the STAAD Pro model have been successfully imported into the RCDC. To have them included in the design, we must first set the design type or the load type for each load case. Here you can see that we have several seismic load cases in both the X and Z directions, along with some dead load, live load, and roof live load. After you have identified the load type for each of the load cases, you're going to go ahead and highlight them and then click on the double right-hand arrow to move them over to the selected area. Once this process is complete, we will go ahead and click OK. After that, the RCDC will want you to generate your load combinations. We're going to use a template for our load combinations, and we're going to select the template for regular structures. Here we have an opportunity to review all of the load combinations that will be generated for this particular model, considering the load types we entered. Once we're done, we'll go ahead and click OK, and then take this as an opportunity to save our model. The next step in our workflow is to specify all of your concrete column and shear wall design settings, and we're going to do that by walking through each of these options through the Settings menu bar. We're going to start with Design Settings. Here you can specify several different design settings for both your columns and your shear walls. After you specify all of these settings, including ductile design and live load reduction parameters, you're going to go ahead and click OK. Next, we're going to take a look at our reinforcement settings. Here you can specify the minimum and maximum reinforcement to be provided for the columns and walls. You can specify your rebar spacings by entering the minimum and maximum rebar spacing settings for various types of reinforcement. Preferred spacings for longitudinal reinforcement is what is considered as the default auto detailing. You can specify your preferred rebar spacing along with your rebar diameters. Your available rebar diameters can be used in the project. The minimum and maximum rebar diameters will refer to the available rebar list for implementation. You can also enter your link shapes and round off factors. Once you're done specifying your reinforcement settings, we'll go ahead and click OK. Next, we're going to specify our detail and drawing settings. Here you can specify some drawing information, some reinforcement labels, your elevations for your levels for elevation, and your laps and splice information. After you're done specifying your detailing and drawing settings, we can go ahead and click OK. Finally, we're going to enter our zone bar settings. Here you can enter your settings for your zone and your rebar settings by entering the information in this table. Once we're done, we'll go ahead and click OK. After you have reviewed your imported load cases and combinations and specified all of your column and wall design parameters, we're then going to proceed to perform the design. In your toolbar, you're now going to click on your Auto Design icon. We can see that all of the columns and all of the walls have now been designed through this process. All of the columns and walls were designed considering the bending moments, any slenderness moments, combined forces, shear design, and also ductility checks. If any of the columns failed, we'd see this bar over at the right-hand side turn red. In addition to that, we would be able to click on Reports, followed by Failure Diagnostics to see if any of the columns have failed. After the column design is complete, you can review your column designs and modify the reinforcement as required. Up in your menu bar item, we are going to highlight a particular column. We'll highlight C1 for this example. And then we're going to select Modify, followed by Redesign Section. And then you're going to notice that the column is going to become available on your screen. From here, you can modify your size of your column, any of your concrete or steel material properties, and any of the other properties included in the design. If you would like to change any of the reinforcement, we could do that at the right-hand side of this dialog. So what we're going to do is we are going to highlight a particular bar on our screen, and then we're going to click on the bar size, say that we want to change it to. Say for this example, we'll highlight a number 19, and we'll click on the bars. Maybe we want some 13s as well. Highlight the bar size you want, and then click on the bars you want to change. If you would like to add reinforcement to the design section, you can click on a bar size and then click on the icon to add a bar. Then you can click any location within the column on the grid to add some reinforcement to it. If you like the modifications that you've made, you can click on your redesign icon over at the left-hand side. If everything passes, it will go ahead and update that column for you, and then you can go ahead and click on the accept icon. If you choose to reject the recommendations, you can click cancel. And here that we can see that the column has been updated on that particular level. In addition to that, you can also review your shear wall design results. Here we'll go ahead and select one of our shear walls. We're going to highlight it and then click Modify, and then we're going to click Redesign Section. And here we're going to see the shear wall is going to appear on our screen. Over at the left-hand side, we can update our material properties, and we could take a look at the wall at each level with the reinforcement that came up during the design. If we would like to update any particular section of this wall, we could double click on it. You could see one of the walls became highlighted, and then we can modify the reinforcement the same exact manner for which we had done for the columns. If we make any changes, we can choose to accept, or we can go ahead and cancel this operation to return back to the previous screen. After the design is complete, you can generate your column schedule and drawings, and also your calculations report. So in the menu bar item, we're now going to select Reports, followed by Text Schedule, and then we'll select Type 1 Ductile Schedule. And here we're going to be able to see our column schedule for each of the columns within our model. In addition to that, we can select Reports, followed by Detailed Drawing, and we can see all our columns and walls in this area as well. And we can see here over at the left-hand side, we have our column and wall schedule, as well as our combined wall schedule. Back up at our Reports menu bar item, we're now going to select Elevation. And here we can see all of our column elevations. You can see this is the column that we actually modified, and that's giving us a cross section at that location. So we have it for each of our columns along with our walls, and we can see our section cuts over here with some more details. If you would like to review your bill of quantities, you can go to your Reports menu and then select Bill of Quantities. And here we can see basically the concrete and reinforcement that's going to be required for the columns and walls of this job. If you would like to generate your BBS report, we're going to go ahead and click BBS, and then we're going to say Generate BBS. And here you can see for each of the columns and walls, we have a bending schedule. Finally, to generate your report calculations, we're going to go back to our Reports menu, and we're going to select Design Summary. And here we can see a design summary for each of the columns and walls in the model. It's going to list the applied loads, axial and flexural loads, the interaction ratio, the main reinforcement, and also the link design. Back up in our Reports menu, we can also finally select Design Calculations. And here you'll be able to see the design calculations for each of the columns and walls in the model. This will provide the general data, your loading data, your effective length calculations, a check for your stability index, a slenderness check, the calculation of the design moment, a moment capacity check, and the design of the shear and link reinforcement. Once you're done, you can go ahead and save your model, and then this would conclude the process for designing your concrete columns and shear walls within the STAAD Pro Advanced Concrete Designer, the RCDC.